Alright, a major application of tangent lines is what's called Newton's method. All Newton's method is going to do is you just keep writing the equation of a tangent line to approximate a zero to the required level of accuracy. For us, a zero in the third decimal place. So we start off with, since we're centering this at 0, which is 1. Okay, and the first derivative is 1 plus e to the x, and f prime of 0 is 1 plus e to the 0, which is 2. So we now know that y minus 1 is equal to 2 times x minus 0. Why? Because our first point when x is 0, y is 1. So y is equal to, oh, hold on, I'm going to say now x is, oh, not x, y is 0. I'm approximating zeros here. I got to make a wake up. So minus 1 is 2x, x is minus 1/2. Now I'm going to calculate f of minus 1/2. Now to do this, I'm going to pull out my graphing calculator. Let me go ahead and I'm going to add a graphs page here. I add a graphs page solely to graph the function. And if you want to, what you can do, and this is not necessarily a bad thing, is, let's see, I want a 0. Okay, so it's a little bit smaller than 1/2. Notice in one step we're already close. Okay, so now I'm going to go f of negative 1/2, and I record that value. Okay, now I find the value of the derivative at negative 1/2. Okay, and I put that here. So, menu, calculus, derivative at a point. Oh, you know what I should have done? Copy. Menu, calculus, derivative at a point. Control V. And in fact, I didn't have to do it that way. There's another way I could have done it. F1 of x, oops, just x, and there's my derivative value. Notice it's a little bit bigger in this, and this will not always happen. So now I write my tangent line, y minus 2.11 x plus 1/2. Okay. Okay, now before I do anything, let me show you what I'm writing down. I now write my equation of my tangent line. If y is 0, I get negative. Okay, I'm going to divide it by the derivative value, and I'm going to subtract 1/2, and that's x. Notice I did that in my head. Now I'm going to pull out my calculator because there's no way that you should be doing this. So 0 minus, copy. Okay, then I'm going to divide this by this, and then I'm going to add x is negative 0.550 dot dot dot. Now let me evaluate the function there. Every TI product, if you go control negative, you can get the previous answer. That's this answer here. Look, we're pretty close. Oh, I wrote the wrong number. Now be careful here. It's very, very easy to copy a number into the wrong place. Now, what we're going to do, menu, oh wait 1 second, hold on, escape, let me get out of here. I'm going to arrow up, there's my 0. So there's my x value that I've approximated. Menu, I'm in calculus class. Derivative at a point, my value. Notice I'm letting the calculator copy and paste everything in there. Okay. The y value of the derivative is 1.576 ... So I write my tangent line, 1.576 x plus 0.550 ... equals y minus 0.026 ... Okay. Now, what I'm going to do is I'm going to let y be 0. So I get negative 0.026 ... divided by 1.5, oops, don't forget the 7 like Mr. Isaac just did, minus 0.550 ... is x. Okay, notice I did all that in my head, but I'm going to use my calculator. One mistake and you are toast. So I'm going to go negative 1 times, there's what I need. Then I'm going to divide that by that. Okay, come on, copy it. Then I'm going to add, because it's a negative number, and I get that x is negative 0.567 yada 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 yada. Now I'm going to evaluate my function there and see if I'm done. Okay, now I'm going to go back and show you some notation that people normally do. 1, 2, 3, 4, 8. Okay. All right. So normally what people do, because this is numerical techniques, so here this would be x1. So that's the first guess. The next one would be x sub 2. And finally, the third guess would be x sub 3. So notice we needed 3 iterations of applying tangent lines to approximate the 0. Now let's go double check our graph, because if my memory is correct, that's what we had. So there's another technique that runs in the background. Most calculators use Newton's bisection method, which is very elegant. It's just very nice. It's just very nice. Maybe someday I'll make a video on the bisection method.